Okay, page 287. I asked you to do numbers 1 to 5. So number 1, 2, and 3 all have to do with this diagram. So number 1 says a car on a roller coaster is moving along as a level section 12 meters high, so that's up here, at a speed of 4 meters per second. When it begins to roll down a slope as shown, determine the speed of the car at point A. So up here would be our initial, and here would be down at point A would be our final. So up here at the top, it has a speed, so the 1/2 mv squared stays. It has a height, so the mgh stays. There is no spring, so this is going to disappear. At A, which is our final spot, it has a speed. It has a height, 4 meters. There is no spring, and there's no E lost yet. Okay, so we have 4 terms, and there's an m in every one, which means you can cancel the m's. Okay, so we have 1/2 v initial squared plus g h initial will equal 1/2 v f squared plus g h final. So we've gotten rid of the m's in each of the terms. Now what is it we're trying to find? We're trying to find the speed, the final speed, this guy. So we can take the GHF over, and so 1/2 v initial squared plus GHI minus GHF equals 1/2 VF squared, and then multiply everything by 2. Okay, so when we multiply this by 2, we'll be left with VF squared is equal to VI squared plus 2GHI minus 2GHF. And now we can fill our values in. Our speed at the top was 4 meters per second, and it's going to get squared, plus 2 times 9.81 meters per second squared, and our height there was 12 meters, minus 2 times 9.81 meters per second squared, and our height at the bottom is 4 meters. Okay, remember when you do this, your VF what you're going to get is VF squared here. Squared, it's going to be equal to 172.96 meters squared per second squared. Take the square root and get 13.1514 meters per second. Okay, so that's your answer to number 1. Number 2 says, what is the height at point B if the speed of the car at that point, so that it's telling us in B that the speed here is going to be 10 meters per second. And it wants to know what's the height. So again, it's going to be the same long equation, and I know it's a pain to write it out, but trust me, as you write it out each time, it gets cemented in your memory. And so then on a test this year, on a test next year in Physics 12, when we get back to it next year in Physics 12, you will know it. And it's not that hard to know, it's just the 3 pieces of the energy. Okay, so 1/2 kx final squared plus E lost, and once again, no E lost and no spring. So I'd probably still pick my initial up here because I know both my height and my speed there, so it still has an initial, and now my new final is over here at B. So at B it has a speed, we were told it's 10 meters per second, and it has a height, that's what we're looking for. So we have these 4 left again. Again, the m's are in every term, so we can cancel them. So again, it'll be 1/2 v initial squared plus g h initial equals 1/2 v final squared plus g h final. This time we're looking, I think it's the same thing. We're looking for VF squared. Okay, so bring your GHF over and multiply by 2. So it rearranges exactly like it did the last time. We should have 2VI squared plus VI squared, not 2, the halves cancel, plus 2GHI minus 2GHF. Fill in your numbers. VI again is 4 meters per second, and it gets squared again. No, I lied. Shoot, I'm looking for HF. Scratch this. So rearranging for HF, it'll be HF equals 1/2 VI squared plus GHI minus 1/2 VF squared. This is why I need you in front of me. And then divide it by G. Okay, so HF equals 1/2. The speed at the top was 4 meters per second squared plus 9.81 meters per second squared. The H initial was 12 meters minus 1/2. The speed here was 10 meters per second squared divided by 9.81 meters per second squared. Sorry about that mistake there. I should really go back and read the question when you're not in front of me. All right, and so when you punch all of that in, you should get an HF to be 7.71865 meters. Okay, so that's number 2. Number 3, what is the height of Y if the speed of the roller coaster at B is 12.5? So now they're changing the speed so that at B this time the speed is going to be 12.5 meters per second. So again, your big long equation, 1/2 mv initial squared plus mgh initial plus 1/2 kx initial squared is equal to 1/2 mv final squared plus mgh final plus 1/2 kx final squared plus E lost. E lost goes to 0, no spring yet. If we keep our point at the beginning, we'll still have these two, and our point at B still these two. Our m's cancel. We're looking for HF, so bring 1/2 VI squared plus GHI minus 1/2 VF squared equals GHF. Divide both sides by G. So HF will equal 1/2 VI squared plus GHI minus 1/2 VF squared over G. So again, 1/2 of 4 meters per second squared plus 9.81 meters per second squared times 12 meters minus 1/2, and this time the VF is 12.5 meters per second squared, and all of it again gets divided by 9.81 meters per second squared. Okay, and so if you think about this, the only difference from number 2 to number 3 is they made the height of the hill higher. And if they made the height of the hill higher, it means they made the speed bigger. And if they made the speed at the top of the hill bigger, it means the height of the hill should be lower, not higher. So when you punch all of this in, you should get an HF to be 4.852 meters. Okay, so hopefully you're getting a handle on the big equation and realizing it's not that bad. All right, let's take a look at number 4, which says you throw a baseball directly upward, giving it an initial velocity of 10 meters per second. Okay, so you're throwing it up, and so the VI down here is 10 meters per second, and the HI is 0. It's starting from a height of 0. Neglecting friction, what would be the maximum height of the ball? So HF up here is what you're looking for. It's going to go up until it stops. So VF should be 0. So 1/2 mv initial squared plus mgh initial plus 1/2 kx initial squared equals 1/2 mv final squared mgh final 1/2 kx final squared plus E lost. Still no friction. I promise it's coming. Still no springs. Down here at the bottom, it has a speed but no height, so the mgh goes. Up at the top, it has a height but no speed. So we're left with 1/2 mv initial squared equals mghf. The m's cancel, to be continued in the next